Okay, now we have another limit as x approaches infinity, and that's a consistent theme here. We're approaching infinity of this strange function. It has two terms. The first term is the square root of 4x squared plus 4, and then minus 2x. That's 2x outside of the radical sign. I'm going to enumerate the steps here. The first thing we're going to do is rationalize the numerator, get the radical out of the numerator by multiplying by the conjugate over the conjugate. So we have the limit of the original function, square root of 4x squared plus x minus a 2x times the conjugate, square root of 4x squared plus x plus 2x over itself, the square root of 4x squared plus x plus 2x. That's a typo. It should be a plus on the bottom, the same as the top. That equals a limit of 4x squared plus x minus 4x squared when you multiplied a squared minus b, a plus b times a minus b. And that's over the square root of 4x squared plus x plus the 2x. We get a cancellation of the negative 4x squared and the 4x squared. And what's left is a limit as x approaches infinity of x over the square root of 4x squared plus x plus the second term, 2x. Okay, now step 2. We're now going to evaluate this new function or this new form of the function by doing the trick that we did in the last example. We want to avoid infinity over infinity, so we're going to multiply by 1 over the largest power of x in the function over 1 over the same largest value of power of x in the function. Okay, when we do that, we will now have the limit as x approaches infinity of x times 1 over x on the top, and then do the same thing on the bottom. That's the square root of 4x squared plus x, and then the second term is plus 2x in parentheses times the same 1 over x that we multiplied the top. We're going to distribute that multiplication across the bottom. Why did we choose 1 over x? Why is 1 over the highest power of x 1 over x to the first power? It's because what do we have to choose from in the function that we started with in step 2? We have 2x, we have the square root of 4x squared plus x, and we have x to the first. Well, 2x, the highest power is first power, and x to the first, the highest power is the first power. The one that's a little tricky is the square root of 4x squared. Well, the square root of x squared is x. So the square root of 4x squared is 2x, see? So we just had to kind of like see what the highest power was if we had evaluated the square root symbol. So it turned out being x to the first power. So that's why we multiply the top and the bottom by 1 over x. Okay, now distributing, we get the limit as x approaches infinity. I don't always write that, but it's there, of 1 on the top when we simplify over. Okay, you got to put the 1 over x under the radical sign for the first one, and it becomes 1 over x squared. Then you distribute it across the parentheses under the radical sign, and then don't forget to distribute the 1 over x times 2x. Simplifying, we get the limit as x approaches infinity of 1 over the square root of 4 plus 1 over x, and then plus 2 for the second term in the denominator. Now we're ready to take the limit. Now we feel assured that we're not going to get a strange infinity over infinity or infinity minus infinity. We get 1 over the square root of 4 plus, because the 1 over x went to 0, so it's just the square root of 4 plus 2, and that simplifies to 1/4. So these are the two tricks that you can use to simplify, algebraically simplify the function to avoid getting the indeterminate form infinity over infinity and 1 over infinity.